Okay, so what happens then if I include another vector? So if we call this one P, let's call this one Q. Okay, so this one's going to be called Q. And I don't know, let's say that that is 2 steps to the left and 2 steps up. So Q, write that as a Q, is 2 steps to the left, so it'd be -2, and 2 steps up. So it'd be 2, -2, 2. If I wanted to write this in IJK notation, what would that be? In IJK notation, so just like this. Good. In IJK notation. Excellent, plus 2j. Now, if I did also want to include a k in there, how could I write that? Excellent. Plus 0k, right?
What does the I is right, k is up, what is the k?
K is 1 step forward. K is 1 step forward. So I haven't written on, I can't draw it on here, but imagine there was 1 step going in the forwards as well. So I is 1 step to the right, j is 1 step up, k is 1 step forwards. Okay. Is there any questions about that? No? Good. Okay, so that's Q. Let me move P over to here then. So just remember that P was equal to 3, 4, wasn't it? Thank you, Samara. Okay. Now you notice in this case, because we're dealing with strictly 2-dimensional vectors, in other words, they just exist left and right and up and down, we don't have to include the k's on there. But if we don't have to include them if we don't want to. How in graphics will it look?
Yeah,
How k would look? Well, k would look forwards and back. So if you imagine doing your left and right and up and down like movement as before, k will be outside. So for example, if I change vector p to be, I don't know, let's say 3, 4, 1, so it'd be plus 1k, okay? Then I'd still move 3 steps to the right and 4 steps up, but now I'd also move 1 step forwards as well. So it'd be movement from this point to this point. So it's like off the board. So it starts in the board, and then it ends in a position off of the board. It's a 3D position. Yeah, exactly. But I mean, just for simplicity's sake, let's keep this as 2 dimensions. Okay. Very good, did you say? I mean, the thing is, if you can understand 2 dimensions, it's not that much more difficult to understand 3, right? So I'm going to stick with 2 dimensions, understand the basics, and then we can apply it to 3. It's not that much more difficult. It's just an extra number there. Okay, fine. Right. Here's my question. What do you think Q plus P will look like? So don't tell me what it is like algebraically, tell me what it means geometrically, because remember we're looking from a geometric point of view. Good, so we're adding 2 vectors together. What does that actually mean from a geometric point of view? Well, let's think about it. It's saying we're moving along Q first. So here's my Q, here's my Q. We're moving along Q first, right? So we're moving from this point down here to this point up here. Is that okay? Yeah? And then we're moving along Q. So if I pick Q up, sorry, then we're moving along P. So if I pick P up, join him to the end of that, because remember that's where we are at the moment. Okay. Now we end up over here. So what we've basically done here is we've moved from this point to this point. You remember that a vector, it doesn't matter how we move between those 2 points, all that matters is that we move from this point to this point. So would you be happy I could describe this as a resultant vector? It's a resultant vector because it's the result of these 2 vectors point together. It's just a movement from that point to that point up there. Okay, that would be Q plus P. Now here's a question for you. What would P plus Q look like? So what if I did P first and then I moved along Q? What would that look like? It is the same thing, but can you convince me why? So what we're literally saying here is we start with P. So let's say we start down here. So we start down here.
The same distance that you went, but the opposite way.
Good, exactly. So then we move along Q, which is this distance from here to here. Okay, let me just move that over a little.
Because the rules of vectors is when you add in the vectors, you need to add from end of the first vector
Excellent.
to the
Good, yeah.
from n to
Exactly.
half of the
All that matters is that we get from one point to another. It doesn't matter how we get between those 2 points. Yeah, good. So would you be happy? Okay, I haven't drawn it brilliantly here, but these two vectors should be the same. So this vector should be the same as that vector. Okay, my notation went off a little bit. It's a little bit drunk, right? So would you be happy that q plus p would be the same as p plus q? They are the same thing. It doesn't matter how we get between those 2 points. All that matters is that we get between those 2 points. Okay. So here's my last question then, and then we'll finish off. How could we describe this thing algebraically? So what I'm saying here is move along P, then a move along Q. Oops, I forgot to underline this. So how could I describe that movement algebraically? How could I describe just this movement here?
3i.
How much you walked on Y and how much you walked on Z?
Yeah, okay, so let's think about it in terms of columns, right? So I'm going to do this one, which is P, so 3, 4. Then I'm moving along Q, which is negative 2, 2. Okay, if I put those two things together, what do I get?
And 6.
1 and 6, because in total I move 3 steps to the right, but then I move 2 steps back. So I've only moved 1 step to the right in total. Okay, and then I've moved 4 steps up, and then another 2 steps up. So I must have moved 6 steps up in total. So in other words, if I'm dealing with this thing, this would be 1 step to the right, and then 6 steps up. And 6 steps up.